We also have another version of IP protocol in use, IP version 6. The initial motivation for development of this protocol was the limited addressing possible within the 32-bit of IP version 4 address. IP version 6 solved this problem with a 128-bit address space. It also addressed a few other concerns in IPv4 towards improving forwarding speed and QoS support. One of the changes towards speeding processing was introducing fixed length header. Remember that IPv4 had options, and with addition of options, the header size could change. The header length announced to the router how much of the datagram should be processed as the header. This takes additional router processing. IPv6 fixed this with a 40-byte fixed length header. IPv6 also does not allow fragmentation and reassembly. Removing this task from the network routers and ensuring the encapsulation and decapsulation of the datagrams only at the source and destination hosts. IPv6 also introduced traffic class field, an 8-bit field that can provide priority to certain datagrams that belong to a flow or a specific application. Flow label is also introduced in IPv6 to facilitate a special treatment of group of packets belonging to a special flow between a sender and a receiver. Next header, similar to protocol field in IPv4, identifies the upper layer protocol, and source and destination address identify the same concept only with higher number of bits used for addressing in IPv6. IPv6 also removed the checksum field. This decision was made because the link layer and transport layer do checksumming, and this functionality in the network layer deemed redundant. Also, we said that IPv6 removed the options to have a fixed length 40-byte header. The IPv6 still has the possibility of adding option fields. This could be done with using pointing of the next header field to the options that are outside of the header. IPv6 also works with new version of the ICMP protocol, ICMP version 6. Development and adoption of IPv6 started from 1990s. The internet with IP version 4 was in place at that time. This means that routers did not have the capacity of processing IP version 6, but they did have the capacity for IP version 4. And we know that in a massive distributed infrastructure, it is not possible to upgrade everything simultaneously. Given the situation, the question is, while upgrade of the routers is in progress, is there a way for making IPv6 compatibility at the IPv4 capable routers? This is achieved using tunneling. In tunneling, an IPv6 datagram is carried as payload in the IPv4 datagram, while passing the routers that are only capable of IP version 4 processing.